In this question, we're told that we have a 120 gram mass attached on the end of a rod that is light and that is rigid. And I've just spotted that I've labelled the rod incorrectly. That's the rod there. So, per usual, let's quickly write down the variables that we have. We have a 120 gram mass. So let's say that m equals then 0.12 kilograms, converting it into SI base units. We have a radius of 80 centimeters. 80 centimeters is equal to 0.8 meters. And we're also told that it has a constant speed. Let's call it v of 4 meters per second. And the circle is vertical. And we're asked to calculate the ratio of the tension in the rod at A compared to the tension in the rod at B. Well, before we delve into this, let's quickly recap some basics to do with the centripetal force at different points, considering we have a vertical circle. When the stone is at point B, then in this free body diagram, we're going to be having the tension acting downwards due to the rod. Also going to have the weight acting downwards due to gravity. This then can be resolved to give us a centripetal force. Let's call that F. F is going to equal the weight plus the tension then. And this again is at point B. Considering at point A, we will still have the tension acting upwards, T. We will still have the weight acting downwards, W. Resolving this would give us then that we'd have a resultant force. This time we can qualitatively see that this would be smaller, and that would be the centripetal force. In this case, the centripetal force upwards is going to equal to the tension minus the weight. Maybe up here it would be a bit better if I did this more consistently, and that I did here that the centripetal force equals the tension plus the weight. So now in using this, we can then apply that to work out this question here. So let's consider at point A, so let's call it T subscript A. Well, here I've labelled that A, and that's A, and so that would be the tension at A. We could then rearrange this equation by adding the weight to both sides to get that the tension at A is equal to the centripetal force plus the weight. Similarly, with the tension at point B, T subscript B, we can say subtract the weight from both sides to get that the tension at B is equal to the force, the centripetal force minus the weight. What is the centripetal force? Well, we're given a mass, we're given a speed, we're given a radius. I'm wanting to use the equation F equals mv squared divided by r. And what's the weight? Well, the weight is equal to mg. Let's input those values in like so. Or input these equations in like so. We have in tension at A, we have mv squared over r plus the weight to equal mg. And the tension at B would then be mv squared over r minus mg. And we can simplify both of these equations, as we can see that the mass is common for out, so we can take the mass out, and that would then be v squared over r plus g. And the tension at B, we can then do the same thing, m into v squared over r minus g. I'm just going to quickly rub this out so I have a bit more space over here on the right. And so, using what we've got here, the two tensions, we can then plug that into our ratio. The ratio would then equal the tension in the rod at A. So this equation, m into v squared over r plus g, and that's all divided by then the tension in the rod at B, which is what we got here, m into v squared over r minus g. And now, as you see here, mass is common throughout. It cancels. We then have v squared over r plus g on the top, all divided by v squared over r minus g on the bottom. Now you may have thought to yourself, well, that was quite a lot of effort to go down that entire route. We could have just determined the tensions, we could have just determined their values and then plugged that in at the end. The reason why I've done this specifically is because in an exam question, in this case, they could have been perfectly within their rights to not give you a mass of the stone. And as you see, this value has been completely unused. It's now not in our final equation here. So in an exam question, you might not have been given a mass, but you would have been able to do the exact same thing. But just remember, don't immediately try and work out the values. Work it through to the end. Now here, it's not exactly needed in this question, but this is quite an ugly fraction. This is known as a 4-stacked fraction. We can times top and bottom by r to then simplify this somewhat, so we get then v squared plus gr all divided by v squared minus gr. Again, not exactly necessary, something you do in mathematics in a Core 4 module. And finally, we can then input in our values that we have. The speed v is 4, so we have 4 squared, then plus g times r, g being 9.81 times r being 0.8. All that divided by 4 squared minus 9.81 times 0.8. And plugging that in on your calculator will give you a value of 2.93. And this would be unitless, as it's just a ratio, and that's been quoted to 3 significant figures.